Good morning, students. So here again, I am with permutations and combination. Fine. So this permutation and combination will come in chapter number 1, that is principles of counting. That is in BCA third semester, subject called discrete mathematical structures. Fine. So if I speak about first semester, fundamentals of mathematics for computer. So this thing will come in third chapter. Again, the chapter name is Principles of Counting. Fine, I have already solved so many problems on permutations and combinations. Still, I wanted to give you some more knowledge about permutation and combination. Fine. So, here, for more complicated problems, we will need to develop two important concepts, that is permutation and combination. Both of these concepts involve what is called the factorial of a number. Fine, both the concepts fine is involved in what is factorial of a number. Fine. So the next thing is fine. So what is factorial of a number? So it is nothing but we have learnt it n factor is equal to n into n minus 1, n minus 2, n minus 3 and so on. Fine. For example, 5 factorial, that is 5 into 4 into 3 into 2 into 1. The sum is 120. Fine. 0 factorial, by the definition it is 1. So here I will start with a wonderful example. Fine. The biology students from PUC will enjoy this example. So how it is used in counting? Fine. Example. Simplest protein molecule in biology is called vasopressin. Fine. I think all of you knows what is vasopressin. And vasopressin is composed of 8 amino acids. Right? Composed of 8 amino acids that are chemically bound together in a particular order. So, vasopressin consists of 8 amino acids which are chemically bonded together in a particular order. The order in which these amino acids occur is of vital importance, is very important to the proper functioning of vasopressin. Right? If these 8 amino acids were placed in a hat, fine, these 8 amino acids are placed in a hat and drawn out randomly one by one. So how many different arrangements of these 8 amino acids are possible? Solution. So let us take these AM8 amino acids and we give them name as A, B, C, D, E, F, G, H. Fine. So there are 8 amino acids and we have named them as A, B, C, D, E, F, G, H. Fine. They must fill 8 slots. Fine. So when these 8 amino acids, that is A, B, C, D, F, G, H, are placed in a hat and drawn randomly, ಅದರ ಅರ್ಥ ಹ್ಯಾಟ್ ಒಳಗೆ 8 ಅಮೈನೋ ಆಸಿಡ್ಗಳನ್ನು ಹಾಕಿ ರ್ಯಾಂಡಮ್ಲಿ ಒಂದೊಂದು ತೆಗೆದು ಈ ಜಾಗದಲ್ಲಿ ಇಡಬೇಕು. ಫೈನ್. ಸೊ ಅಟ್ ಫಸ್ಟ್ ವಿ ಗೆಟ್ 8 ಚಾಯ್ಸಸ್. ಫೈನ್. ಫಸ್ಟಿಗೆ ಎಷ್ಟು 8 ಎಚ್ ಒಳಗೆ ಯಾವುದಾದ್ರೂ ಒಂದು ತೆಗಿತೀವಿ. ಫೈನ್. ಸೊ ಸೆಕೆಂಡ್ ಪಾಸಿಬಿಲಿಟಿಯಲ್ಲಿ ಎಷ್ಟು ಸಿಗ್ತಾವು? 7 ಸಿಗ್ತದೆ. ಸೊ ದೇರ್ ಆರ್ 8 ಚಾಯ್ಸಸ್ ಅಟ್ ಫಸ್ಟ್, but at second we left with 7 choices, and at third we left with 6 choices. Like that, the number of different ordering is 8, 7, 6, 5, 4, 3, 2, 1. That is nothing but 8 factorial. That is totally we can randomly choose 8 amino acids in 40,320 ways. This is the best examples you can get. Fine. So when we further proceed, of 40,320 amino acids, possible ordering of 8 amino acids, the human body can use just one. A cell uses one amino acid. Then what is the probability that the random chance alone with no outside interference, the correct order occurs? We will discuss probability in coming chapter, but there is an answer. The probability of correct order is 1 upon 40,320, which is an extremely unlikely event. So for more complicated biological molecules such as hemoglobin with many more amino acids, the probability that correct order occurs by random chance alone is extremely small, close to 0 factorial, that is 1, which raises the question in some scientists' mind of just how such a molecule can be formed by a random choice. Some have concluded that their creation was not due to the random choice, but it is an intelligent design, which raises still more questions that cannot be completely answered. Fine. So two problems illustrating combinations and permutations. So consider two problems. Consider a set P comma N E comma N. So how many two-letter words can be formed from the members of this set? So we have done fine. That is 3P2. That is 6. So we will list all the possibilities. That is PE, PN, EN, EP, NP, NE. That is a total 6 possibilities. Now consider the set of 3 males, Paul, Ed, and Nick. For simplicity, we will denote them as PEN. How many 2 men crews can be selected from this set? That is PE, Paul, and Ed. That is PN, Paul, and Nick, and EN, Ed and Nick. That's all. Here in the first, there are 6 possibilities can be formed from the member of this set, whereas here 1, 2, 3. Fine. How many 2 men crew can be selected? Fine. This is what? Combination and permutation. Fine. So the difference between permutations and combinations. Now, by having this previous, we'll come to know there is a difference between permutation and combination. Is it? So by looking into these two examples, you have a doubt in what is the difference between combination and permutation. So that we'll discuss the next slide here. Fine. So the difference between permutation and combination is that is both problems involved in counting. Even permutation and combination involves in counting. The number of arrangements of the same set, that is P, E, N, taken two elements at a time without allowing repetition. However, in the first problem, the order of arrangement mattered. That is PE, EP. This PE and EP are two different words. In the second problem, the order do not matter since PE and EP represented the same two-man crew. So we counted this as only one. Fine. So I think you come to know the difference. So the first example was concerned with the counting of numbers, that is permutation. So PE and EP are different words in terms of permutation, whereas PE and EP represent the same in terms of combination. That's what the difference between permutation and combination. So the first example was concerned with what? Counting the number of permutations of three objects taken two at a time. The second example was with the number of combinations of three objects taken two at a time. Fine. So permutation is nothing P of n comma r, which we have already discussed, represents the number of permutations, that is arrangements of n objects taken r at a time when r is less than or equal to n. In a permutation, the order is very important. In our example, we have p of 3 comma 2, which represents the number of permutations of three objects taken two at a time. Fine. In our case, p of 3 comma 2 is 6, that is 3 into 2. In general, the formula is p of n comma r is n into n minus 1, n minus 2, n minus 3, and up to n minus r plus 1. Fine. More examples. Find p of 5 comma 3. Here n is equal to 5, r is equal to 3. So we have p of 5 comma 3, that is 5 into 5 minus 1. Fine. 5 into 5 minus 3 plus 1, that is 5 of 4 into 3, that is 60. This means there are 60 arrangements of 5 atoms taken 3 at a time. Application. How many ways are 5 people sit on a park bench if bench can only have 3 seat people? Find solution. Think of the bench as 3 slots A, B, C. There are 5 people that can sit in the first slot, leaving 4 remaining people to sit in the second position and finally in the third, eligible for the third slot. Thus, there are 5 into 4 into 3, that is 60 ways the people can sit. The answer could have been found using permutation formula phi of 5 comma 3 is equal to 60, since we are finding the number of ways of arranging 5 objects taken 3 at a time. Fine. So the thing is here we go to the combination. In the second problem, the number of two men crew that can be selected PEN was found to be 6. This corresponds to the number of combinations of three objects taken at two at a time, or we can say combination of, that is C of 3 comma 2. We will use a variation of formula for permutations to derive a formula for combinations. Consider 6 permutations of PEN which are grouped in 3 pairs of 2. Each pair corresponds to one combination of 2. Fine. That is P, P, N, E, N. E, P, N, P, N, E. So if you want to find the number of combinations of three objects taken two at a time, we simply divide the number of permutations of three objects taken two at a time by 2. So we have the result, that is C of 3 comma 2 is equal to P of 3 comma 2 divided by 2 factorial. Fine. This is what? Generalization. So C of n comma r is what? Permutation divided by r factorial. Means we select that what we select will be get divided by the total number of permutation. Fine. So let us have some more examples. Fine. So see here it is C of 8 comma 5, here C of 8 comma 8. So these are some examples. Right. So in continuation, when we are used to choose combination or permutations. So in how many ways you can choose 5 out of 10 friends to invite them to a dinner party. And I think we have solved one example. Fine, a woman has 10, I think, close relatives, out of which she wants to invite them for you for the dinner. In the same way, it is out of for you, sorry, out of 10 friends, he wants to invite for you people for a dinner party. Does the order of selection matter here? Fine. If you choose the friends in that order A, B, C, D, E, or A, C, B, D, E, the same set of five was chosen. So we conclude that the order selection does not matter. We will use the formula of combination here because the order of selection does not matter. Out of 10 we are supposed to select 5 for a dinner party. So that is what? Permutation of 10 comma 5 divided by 5 factorial. That is called what? Combination. Fine. So the answer is 252 ways. We can see the answer here. But so we can invite 252 different ways, 5 out of 10 friends for a dinner party. Fine. So one more thing is, when again the question comes here, when we are supposed to use permutation and combination. Fine. In how many ways you can arrange 10 books on a bookshelf that has space for only 5 books. ಸೊ 10 ಬುಕ್ಗಳಲ್ಲಿ 5 ಬುಕ್ಗಳನ್ನ ಶೆಲ್ಫ್ ಅಲ್ಲಿ ಹೆಂಗ್ ಇಡ್ತೀರಾ? ಜಾಗ ಇದೇ ಬುಕ್ಕಿಗಿದೆ. ಡಸ್ ದ ಆರ್ಡರ್ ಮ್ಯಾಟರ್? The answer is yes. The arrangement of ABCDE is different from the BACDE. So we will use the formula for permutation. So whenever the order matters, in that case we will use permutations. Whenever the combination matters, I mean to say order does not matters, we will use combination. So, ABCD is different from BACD. So we will use formula for permutation. So we need to determine the number of arrangements of 10 objects taken 5 at a time. So there are 10 objects, we will take 5 at a time. So we have permutation of 10 comma 5, that is 30,250 different arrangements of 5 books in a shelf out of 10 books can be made. Fine. So let us have a lottery problem here. A certain state lottery consists of selecting a set of 6 numbers randomly from a set of 49 numbers. There are 49 numbers, out of which select 6 numbers, which is lottery, randomly from a set of 49 numbers. To win the lottery, you must select the correct set of 6 numbers. How many possible lottery tickets are there? Fine. Solution. The order of the number is not important as long as you have the correct set of six numbers. To determine the total number of lottery tickets, we will use the formula for combinations and find C of 49, comma 6. The number of combinations of 49 items taken 6 at a time using our calculator is that it is 1 crore 39 lakh 83,816 combinations of numbers you can have. So out of which you have to select one number and you can announce that this number is a winning number. Fine. So this is very good example. Very good example. Fine. So, example, three married couple are to be seated in a row, having six seats in a cinema hall. If spouses are to be seated next to each other, in how many way they can be seated? Find also the number of ways they're sitting if all ladies sit together. ಅಂದ್ರೆ ತ್ರೀ ಮ್ಯಾರಿಡ್ ಕಪಲ್ಸ್ ಅದಾರೆ ಗಂಡ ಹೆಂಡತಿ ಮೂರು ಗಂಡ ಹೆಂಡತಿ ಅದಾರ ಆ್ಯಂಡ್ ದೇ ಹ್ಯಾವ್ ಟು ಬಿ ಸಿಟೆಡ್ ಇನ್ ಎ ರೋ ಆರು ಸೀಟ್ ಒಳಗೆ ಕುಂದಿರ್ಸ್ಬೇಕು ಅವ್ರಿಗೆ ಹೆಂಗೆ ಕುಂದಿರ್ಸ್ತೀರಿಪ್ಪ ಗಂಡ ಹೆಂಡತಿ ಕೂಡಿ ಕುಂದಿರ್ಬೇಕು ಅಥವಾ ಫಸ್ಟ್ ಎಲ್ಲ ಗಂಡ್ಮಕ್ಳು ದೆನ್ ಹೆಣ್ಮಕ್ಳು ಕುಂದಿರ್ಬೇಕು ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ ಸೊ ಲೆಟ್ ಅಸ್ ಡಿನೋಟ್ ದ ಮ್ಯಾರಿಡ್ ಕಪಲ್ಸ್ ಬೈ S1 S2 S3 where each couple is considered to be a single unit. So S1 means one male and one female. That is what couple. Fine. Then the number of ways in which spouse can be seated next to each other. That is 3 factorial. That is 6 ways. Again, each couple can be seated in 2 factorial ways. Thus, the total number of sitting arrangements so that the spouse sit next to each other is 3 factorial into 2 factorial into 2 factorial into 2 factorial. Because why? They have used 2 factorial 3 times because there are 3 sitting arrangements. 3 sitting arrangements. That's why it is taken 3 2 factorials. That is the answer is 48 different ways a spouse can sit next to each other. Fine. Very good example. Thus, the ladies and women can be arranged together themselves in 2 factorial ways. Therefore, the total number of ways where the ladies sit together, fine, that is 3 factorial into 3 factorial into 2 factorial, that is 144. And one more example we will take here. Since in a small village there are 87 families, out of which 52 families have almost 2 children. In a rural development program, 20 families are to be chosen for the assistance, of which at least 18 families must have at most 2 children. In how many ways can the choice be made? ಕನ್ನಡದಾಗ ಹೇಳ್ಬೇಕಪ್ಪ ಅಂತಂದರೆ ಒಂದು ಹಳ್ಳಿಯಲ್ಲಿ 87 ಫ್ಯಾಮಿಲಿಗಳಿದಾವೆ. ಅದರಲ್ಲಿ 52 ಫ್ಯಾಮಿಲಿಗಳಲ್ಲಿ 2 ಮಕ್ಕಳಿದ್ದಾವೆ ಅವ್ರಿಗೆ. ಯಾವುದೋ ಒಂದು ರೂರಲ್ ಡೆವಲಪ್ಮೆಂಟ್ ಪ್ರೋಗ್ರಾಮ್ ಅಥವಾ ಸ್ಕೀಮ್ ಬಂದಿದೆ. ಅದರಲ್ಲಿ 20 ಫ್ಯಾಮಿಲಿಗಳನ್ನು ಚೂಸ್ ಮಾಡಬೇಕು. 52ರಾಗ 20 ಫ್ಯಾಮಿಲಿಯನ್ನು ಚೂಸ್ ಮಾಡಬೇಕು. ಔಟ್ ಆಫ್ ವಿಚ್ 18 ಫ್ಯಾಮಿಲಿ ಮಸ್ಟ್ ಹ್ಯಾವ್. 20ರೊಳಗೆ 18 ಫ್ಯಾಮಿಲಿಗಳಲ್ಲಿ ಏನಿರಬೇಕು? 2 ಮಕ್ಕಳೇ ಇರಲೇಬೇಕು. In how many ways the choice can be made? Fine. It is given that total there are 87 families and 52 families have at most 2 children, so that 35 families are of other type. That is 52 minus 87 ಮಾಡಿದಾಗ 35 ಫ್ಯಾಮಿಲಿಗಳು ಬೇರೆ ಟೈಪ್ ಅದಾವಂತ ಗೊತ್ತಾಯ್ತು. According to the question, for rural development program, 20 families are to be chosen for the assistance. of which at least 18 families must have two children. Thus, the following are the number of all choices. That is C, comma 52 C of 52 comma 18 into C comma 35 comma 2. So 18 families having at most two children and two selected from the other type. Andre 18 C of 52 comma 18. ಸೊ ಇದರಲ್ಲಿ 18 ತಗೋತಾರೆ, 52ರಲ್ಲಿ 18 ತಗೋತಾರೆ, ದೆನ್ ರಿಮೈನಿಂಗ್ 32ರಲ್ಲಿ 2 ತಗೋತಾರೆ. ಫೈನ್. ಹಾಗೆ 52ರಲ್ಲಿ 19 ತಗೋತಾರೆ, ದೆನ್ 35ರಲ್ಲಿ 1 ತಗೋತಾರೆ. ಫೈನ್. 19 families having at most 2 children and 1 selected from the other families. So 52ರಲ್ಲಿ 20 ತಗೋತಾರೆ. All selected 20 family having 2 children. Hence the total number of possible choices, that is C of 52 comma 18 into C of 35 comma 2 plus C of 52 comma 19 into C of 35 comma 1 plus C of 52 comma 20. So you can solve this and you can have what answer. Fine. So these are the different examples on permutations and combinations, students. I think this PPT has helped you a lot to understand the difference between permutation and combination. Fine. So here I will stop this class. Thank you. Thank you very much.